Let's be honest, when you hear the word statistics, what pops into your head? For a lot of us, it's, complex math, maybe some scary-looking formulas. But what if we've been looking at it all wrong? What if statistics isn't just math? What if it's a language? A really powerful one that helps us make sense of pretty much everything.
I mean, think about it. Every single day, we're just getting buried in a tidal wave of information. You've got news headlines, business reports, what's trending on social media. It's just this constant, overwhelming noise. So the million-dollar question is, how do we possibly sort through all of that? How do we find the actual signal, the truth, that's hidden inside all the static?
Well, that is exactly where this language comes in. Statistics gives us the tools we need to cut right through that noise. It helps us take all that messy, raw data and translate it into something that's clear, something we can understand, and most importantly, something we can actually use.
So here's the game plan for how we're going to do this. We're going to start with how we turn raw data into smart decisions. Then we'll get into visualizing the story that's hiding in your data. After that, we'll figure out how to find its center, its core message. And finally, we'll use all that to predict the future. It's a pretty straightforward journey from noise to actual knowledge.
Okay, first things first, let's look at the big picture. How does this all actually work? I mean, how do we really go from a spreadsheet that's just jam-packed with numbers to a genuinely smart decision?
It really boils down to this super simple three-step process. First, you have to see your data. You got to get a feel for its shape, its patterns. Then you summarize it, boiling it down into just a few key numbers. And then comes the really fun part. You predict. You use what you've learned to make an educated guess about what's going to happen next. See, summarize, predict. Simple, right? So let's start with C.
This first step is all about one thing: visualization. Because really, before you can do any fancy math, the most powerful and, the most human thing you can do is just look at your data. It's all about turning those boring numbers into a story you can actually see with your own eyes.
And to do that, we've got this awesome toolkit full of different charts and graphs. So let's just do a quick tour of 3 of the most essential tools that, trust me, you're going to find yourself using all the time.
First up, the good old bar graph. You've seen these everywhere. Its entire job is to let you compare different things side by side. Just by glancing at this chart, you can see, bam, product A crushed product B in every single quarter. And hey, it looks like Q2 was the best for both of them. You didn't need a calculator for that. The insight is just right there. It's totally visual.
Okay, on to our next tool, the histogram. Now, this one's a little different. While a bar chart is for comparing separate things, a histogram shows you how often different values pop up in one big group of data. Its whole purpose is to show you the underlying shape of your data, what we call its distribution.
I absolutely love this analogy. Think of a histogram as the skyline of your data. The tallest buildings in the skyline show you where most of your data is hanging out. So in this chart of age groups, for example, you can see in a split second that the biggest cluster of people is between 31 and 40. It's just a fantastic snapshot of the whole picture.
And our third and final visual tool is the pie chart. So if bar charts are for comparing and histograms are for seeing the shape, pie charts have one very specific, very important job, showing you how a whole thing is divided into different parts. So anytime you need to see how a whole pie is sliced up, this is your go-to. Take a company budget, for instance. You look at this, and it's instantly totally obvious that salaries are the biggest slice of the pie. It immediately answers that question. So what are we spending the most money on? All right, so we've nailed the C step. Now it's time to move on to summarize. Looking at visuals gives us that great big picture view, but sometimes we need to be more precise. We need to boil that whole picture down into just a few powerful representative numbers. What we're really looking for here is the heart of our data. You could almost think of it as its center of gravity. The whole goal is to be able to describe an entire massive data set with just a single number that represents it well. It gives us a landmark, a point of reference. And one of the best ways to find our way around our data is by using something called quartiles. Now, don't let the fancy name scare you off. All quartiles are 3 points that chop up your data into 4 equal chunks. Seriously, just think of them like milestones on a road trip marking the 25%, 50%, and 75% points of your journey. So how do we find these milestones? The process is actually super simple. First, you just line up all your numbers in order, from the smallest to the biggest. The number that's a quarter of the way in, that's your first quartile, or Q1. The number that's dead in the middle, that's the median. And the one that's 3/4 of the way through is your third quartile, Q3.
That's it. That's the whole idea. Now, okay, you're going to see a formula like this, and maybe your brain just wants to shut down. But wait, all this is the official, formal recipe for finding that first milestone. It's just the really precise mathematical way of figuring out exactly where that 25% mark is. It's not magic, it's just a very specific set of instructions to get the job done.
All right, this brings us to the final step in our journey, and honestly, maybe the most powerful one of all: predict. We've seen our data, we've summarized it, now let's use it to peek into the future. This is where things get really cool.
So take a look at this. It's just a cloud of data points, right? Each little dot could be anything, really. Maybe it's sales versus how much was spent on advertising, or maybe it's hours spent studying versus the final exam score. At first, it just looks like a random mess. But what if there's a hidden trend in there? What if we could draw one single straight line through that cloud that perfectly captures the relationship?
Well, that's precisely the magic of what we call simple linear regression. It's this incredible method that finds the one and only line of best fit that slices right through that data cloud. And that line becomes our prediction engine. And believe it or not, every single straight line in the universe can be described by this one little equation. You can think of it as the blueprint for our prediction engine. Yeah, it might look a little bit like algebra class, but once we break it down, it's actually really straightforward.
So let's just translate this into plain English, right? Y is just the thing you're trying to guess. A is your starting point, basically where the line begins. B is the slope. That's just how steep the line is. And X is the piece of information you already have. So all the formula is really saying is what you want to guess equals your starting point plus the steepness of the relationship times the thing you already know. That's it. That's the big idea behind regression.
And that's really the whole journey in a nutshell. We start by making charts and graphs to see the story in our data. Then, we boil it all down into a few key numbers to summarize the main point. And finally, we use what we've learned to build a model that helps us predict what could happen next. See, summarize, predict.
So what we've really just done is learn the basic grammar of the language of data. And it's a language that's being spoken everywhere, all around you, every single day, in every possible field. So I guess the only question left is, now that you're starting to speak the language, what stories are you going to find?